Picture cancer cells as ambitious travelers planning a global tour, initially confined to their hometown in the colon. They may linger quietly, limited by surrounding tissue and the body's natural defenses. But a new study in Nature Metabolism reveals that sugary drinks, sodas, sweetened teas, and energy drinks act like silent travel agents, providing the resources and metabolic support that enable cancer cells to embark on their dangerous journey. The sugars these drinks contain, glucose and fructose, are processed by the enzyme SORD, or sorbitol dehydrogenase, transforming ordinary beverages into a potent fuel source that enhances cancer cells' ability to move, survive, and colonize distant tissues. While sugar doesn't create cancer from scratch, it can accelerate the spread of existing tumor cells, effectively helping them pack their bags and take off on what researchers call metastasis. The mechanism is both fascinating and illuminating. Glucose floods the energy pathways of cancer cells, producing ADP that powers movement and cellular activity, the equivalent of providing jet fuel for the journey. Fructose, converted by SORD, supplies structural components like nucleotides, lipids, and proteins, reinforcing the cell's integrity and enabling it to endure the stresses of travel through the bloodstream. Together, these sugars provide both the energy and materials cancer cells need to leave their original site, traverse complex environments, and establish colonies in distant organs. It's a highly efficient system, a silent partnership where sugar and SORD cooperate to give cancer cells a competitive advantage. The positive takeaway is that understanding this partnership opens the door to multiple avenues of intervention. By identifying SORD as the key metabolic facilitator, researchers now have a precise target for therapy. Drugs that inhibit SORD could effectively remove the fuel from the equation, slowing the mobility of cancer cells and reducing the likelihood of metastasis while sparing healthy tissues. This represents a major step forward in precision medicine, targeting the specific pathways cancer cells exploit rather than relying solely on broad, toxic treatments. It's a clear demonstration of how deep biological insight can translate into actionable strategies for improving patient outcomes. For individuals, the study highlights the power of everyday choices. Reducing sugary drink consumption becomes a tangible and effective way to limit the metabolic support cancer cells rely on. Replacing soda and other sweetened beverages with water, unsweetened teas, or naturally flavored sparkling water helps create an internal environment that is less hospitable to cancer's global tour. Even modest changes, consistently applied, can meaningfully reduce the resources available to tumor cells, slowing their ability to move and spread. This gives people a sense of agency. Small dietary adjustments can have real impact on cellular behavior and long-term health. This research also underscores a broader principle about the connection between diet, metabolism, and disease. What we consume affects more than energy levels or weight. It directly shapes the behavior of cells at the molecular level. By identifying the critical combination of glucose and fructose and the enzyme SORD as key contributors to cancer spread, scientists have revealed a pathway where both lifestyle interventions and future therapies can converge to improve outcomes. The internal environment can be influenced, and cancer's journey can be strategically slowed or disrupted. So, while sugary drinks may act as silent partners in cancer's global tour, this study transforms the narrative into one of hope and empowerment. Knowledge of the sugar SORD pathway provides both researchers and individuals with the tools to intervene. Through informed dietary choices and the potential development of SORD-targeted therapies, we can slow metastasis, reduce the impact of cancer, and preserve long-term health. Far from a story of inevitability, it is a story of insight, strategy, and optimism, a reminder that both science and everyday decisions can meaningfully influence the course of disease.